Hi, this is Rich Evans. I'm going to explain in this video how to solve polynomial inequalities, both graphically and algebraically. Now, in this first example, you can see we have x squared minus x minus 5 is greater than or equal to x minus 2. Now, if we look at the expression on the left side of the inequality, since that has an x squared in it, right there, we know that that would be a parabola when graphed. So that's going to be the parabola. And if we look at the other equation on the other side, x minus 2, that would just be a straight line. So that's going to be the line graph. And so what we're really interested in is, since this says that the parabola is greater than or equal to the line, we want to interpret that as meaning that the parabola's graph is higher than or equal to the line's graph. So we're looking for the part of the graph where the parabola is higher than the line. And the reason we're looking for where it's higher is because of this symbol being greater than. If it was less than, we'd be interested where it was lower. So greater than means higher, less than would mean lower. So we want to find where's the parabola higher than the line. Well, the places where that happens is right in here. You can see that parabola is higher than the line there, and over here. It doesn't happen in this area because there the parabola is actually under the line. So we want to find the x values that corresponds to. So the x value at this point here looks like it'd be -1. And the x value here looks like it would be 3. So it's going to happen for all x less than or equal to -1, or x greater than or equal to 3. Okay, which would include all of these x values over here and all of these x values on the far right side. Okay, the solution is always the set of x values along the x-axis that corresponds to the graph. Let's try the next one. Again, in this case, the first expression has an x squared, so we know that's going to be the parabola. And the other expression doesn't have an x squared, so that's going to be the line. And in this case, since the symbol is less than, we're looking, where's the parabola lower than the line? And the place where that happens is right in this region here. I'm going to circle it. That parabola is lower than the line. But we want the set of x values that matches up with that. So, looks like from there up to here, and all the x's in between. So in this case, the solution would be -1 is less than x is less than 2. In other words, x is between -1 and 2. And we're not going to include the equalities on these, since the equality is not included in the original problem. Okay, now we have one more of these graphical ones. Again, expression on the left is the parabola, because we know that because it has an x squared. The expression on the right is the line. We want to know, where is the parabola lower than the line? Remember, less than means lower. But the parabola is never lower than the line. You can see that from the graph. So in this case, there's no solution because it never happens. Now we're going to turn our attention to how to solve the inequalities algebraically. That's when we don't have any graph available. And the process I'm going to show you assumes that you have a 0 on the right side of your inequality. You can see we do have that in A. But if we ever come across a problem where we don't have a 0 there, we'll have to either add something to both sides or subtract something to both sides so that we get a 0 there. And what we're going to do with the left side is we're going to attempt to factor it, because we need to find where it equals 0 first before we can figure out where it's less than or equal to 0. So in order to find out where it equals 0, we want to factor it and set each factor equal to 0. So in this case, it would factor into x plus 5, x minus 3 is less than or equal to 0. Now the zeros, the x values that make it equal to 0 would be negative 5 and positive 3. We can tell that by looking at the factorization. So negative 5 and positive 3. And what we do with those zeros is we make a number line and we plot those zeros on the number line. And that would separate the number line into 3 distinct parts. We have the part on the far left, we have the part in the middle, and the part on the far right. Those are called test intervals. And we're going to pick a number inside each test interval called a test value. And we can use any number we want as long as it's inside the interval. I'm going to use negative 6 as a test value for the left test interval, 0 for the middle one, and 4 for the right one. And for each one of these test values, we want to substitute it into the inequality and see whether we get a positive or a negative result. So if we take the negative 6 and we plug it into this factored version here, we have negative 6 plus 5. Now that's negative 1. All I really care is that it's negative. So I'm going to write a negative. And then it's going to be multiplied times, we take that negative 6 minus 3. That's negative 9. All I really care is that it's negative. The 9 is irrelevant. So we have a negative times another negative, which will give you a positive answer. I'm going to circle that because that represents the final result. Let's do the same thing with 0. Again, we'll plug 0 in for x here and for there and see whether each one comes out positive or negative. So when we plug 0 into the left one, we get 0 plus 5. So that's 5, so that's positive. And when we plug it into the right one, we get 0 minus 3. That's negative 3, so that's negative. And since you're multiplying a positive times a negative, you would get a negative answer for your final result. And then for 4, we get 4 plus 5, that's 9, so positive. And 4 minus 3 is 1, so that's also positive. So it's a positive times another positive, which is, of course, a positive answer. Now, from here, we want to pay attention to the symbol that's in the problem. We want to know when it's less than or equal to 0. Now, less than 0 means negative. So we want to look to see where the results came out to be negative here. The only place where the results came out to be negative is in the middle test interval. So the solution set will be the middle test interval. It will include, I'm going to do it in red, all the x values between negative 5 and 3. Now, whether or not the endpoints are included depends on whether the original inequality symbol has an equals in it, and it does in this case. So the ends will be included. I'll fill them in with a solid dot. And so the solution set would be negative 5 is less than or equal to x, which is less than or equal to 3. That's an inequality that represents that set of numbers. And that would be your answer. All right, now let's do the same thing for this second example. Let's check. We already have a 0 here, so that's good. The left side's already been factored for us, so that's even better. That's less work we need to do. So we want to know where the zeros are. So the zeros in this case are going to be positive 1 and negative 4. Because if we set x minus 1 equal to 0 and we solve it, we get x equals 1. And when we set x plus 4 equal to 0, and solve it, we get -4. Now we'll make a number line. Let's see here, make a number line. We'll plot our two zeros, -4 and 1. We'll pick test values. I'm going to use -5, 0, and 2. We'll plug those in one at a time. So for -5, we'd have -5 minus 1. That's a negative. And -5 plus 4. That's another negative. So you'd have a negative times another negative, which would be a positive answer. For 0, when we plug it in, we'll have -1 times a positive 4. So a negative times a positive would be a negative answer. And for 2, 2 minus 1, that's positive. 2 plus 4, that's also positive. So it's a positive times a positive, which is a positive. Now, we decide whether to use the positives or the negatives in our final solution based on what the symbol is in the problem. This time it says greater than 0. That means positive. So we want to pick the positive one here along with the positive over there. And it would not include the middle one. So the solution set would include these x values here that make it positive and these over here. The endpoints would not be included in this case because there's no equality in that symbol. So you would have an open circle. And to write that as an inequality, you'd have to say x is less than -4, and you use the word or to combine it with the other side, or x is greater than 1. In the next example, notice we don't have a 0 on the right side, so we'll have to take care of that first. Subtract 25 from both sides. And then we'll factor, so it'll be x plus 5 times x minus 5 is greater than 0. The zeros would be -5 and +5. So we'll plot those on a number line. Here's -5, here's +5. There's 3 test intervals. For test values, I'll pick -6, 0, and 6. And then when I substitute those into the problem, let's start with a -6, plugging it into this factored version here. So -6 plus 5, that's negative. And -6 minus 5, also negative. So it's a negative times a negative, which is a positive answer. For 0, we'll get 0 plus 5, that's positive. 0 minus 5, that's negative. So a positive times a negative, which is a negative answer. And for 6, 6 plus 5 is 11, that's positive. 6 minus 5 is 1, also positive. So it's a positive times a positive, which is a positive answer. And in the original problem, since we have a greater than 0, we're looking for the positive answers. So positive here and there. So the solutions will be on the far left and on the far right, and they will not include the endpoints. So our solution here would be x is less than -5 or x is greater than 5. Okay, next one is a similar idea. First thing to notice is you don't have a 0 here, so you have to subtract 5 from both sides of the equation. Then factor, so it's going to be x minus 5 times x plus 1. The zeros are x equals 5 and -1. So we'll make our number line and we'll plot those 2 zeros on there. Again, we have 3 test intervals. By the way, you don't always have 3 test intervals. Sometimes you can have just 2 test intervals. You can have more than 3. In fact, sometimes there's no zeros, so there's just one big test interval. So it can come out different ways. All right, now our test values for, I'm going to pick a -2 here, and a 0, and a 6. And now we're going to take these values and plug them into our factored version here. So we have -2 minus 5, that's negative. -2 plus 1, also negative. So it's a negative times a negative, that's a positive. For 0, we're going to get a negative times a positive, which is a negative. And for 6, we get a positive times a positive, which is a positive. Since we have a greater than 0, we're looking for the positive, so we have the far left and the far right again. So, far left, far right. We're not going to include the endpoints because there's no equality in the original symbol. So we would have x less than -1 or x greater than 5. That's called a solution set. Okay, same thing here, except the factoring is going to be a little more difficult. We do have the 0 already, so that's no problem. But notice there's 4 terms here. So we'd want to try to use grouping to factor this. So you group the first 2 and the second 2 together. You take the common factor out of the first 2, which would be x squared. That leaves you with x plus 1. What I usually do when I use grouping is whatever I get in parentheses on the left side, I leave a blank space and I copy it over on the right side because it's got to match. And then I figure out what would I need to put in front of that second set of parentheses that would make it multiply out to equal -4x minus 4. And the answer is -4. So then the x plus 1 that's on both sides becomes a common factor and goes out front and inside parentheses. And then the x squared and the -4 combine together to make the other factor. And let's not forget our greater than or equal to 0. And this second factor factors again into x plus 2, x minus 2. So we'd actually have x plus 1, x plus 2, x minus 2 is greater than or equal to 0. So the zeros are -1 in this case, -2, and +2. So when we make our graph, we have to plot all 3 of those. So -2 here, -1 there, and +2 over here. So for test values, I'm going to pick -3. Now for in between -2 and -1, I've got to go with a decimal there, so I'm going to use -1.5. And then 0 would work for this one, and 3 for this one. Okay, same drill as before. We're going to take these 4 test values one at a time, starting with a -3, and substitute it into this factored version here. So -3 plus 1, that's negative. -3 plus 2, negative. -3 minus 2, that's negative. All 3 are negative, so you have 3 negatives multiplied together. What kind of an answer do you get when you multiply 3 negative numbers together? I think if you think about it, you realize that's a negative answer, because the first 2 negatives cancel out and give you a positive, and then you multiply that times a negative. Alright, for the next one, -1.5, you would get a negative, a positive, and a negative. So negative, positive, and a negative. That would give you a positive answer because the 2 negatives would cancel each other out. For 0, we get a positive, and a negative. Positive, positive, negative, that would be a negative answer. And for 3, all of them are positive. So you have 3 positive numbers which multiply out to equal a positive answer. Since the symbol in our problem is greater than or equal to, we're looking for the positive, so that would be this one and this one. So it's the x values for those on the number line. Really, that's our solution set. And this one does have an equal sign as part of the symbol, so we would include the endpoints. I'll fill those in with solid dots. This side goes forever. So our solution set would include this left one you can express with a double inequality. You'd say -2 is less than or equal to x, which is less than or equal to -1. And then you'd use the word or, and then for this one you just say x is greater than or equal to 2. So or x is greater than or equal to 2. Now we're going to look at an application. We have a function here, s of t equals -16t squared plus 32t plus 1920, gives the height s in feet of an object thrown upward with a velocity of 32 feet per second from a cliff that is 1920 feet high. Time is in seconds, and that's t, and s represents the height of the object in the air. And part A says, for what times is the height greater than 1920? So this whole expression on the right-hand side of this function represents the height. And we want to know when the height is greater than 1920. So we'd set that up by writing the whole expression that represents the height. And setting that to be greater than 1920. Now we know we need a 0 on the right hand side, so we'll have to subtract 1920 from both sides. That makes it cancel out on both sides, and will give us a 0 on the right side. And then we need a factor, so I'm going to factor out a -16t, which leaves us with t minus 2. The roots are going to be t equals 0 and t equals 2. So when we make our graph, we need to plot 0 and 2. Now remember, this horizontal axis represents time, or t. And time equals 0 represents the moment when the object is thrown upward. For the time that's before time equals 0, over here, is really irrelevant in this problem. So I'm going to cross it off. We don't really have to worry about that at all, because that doesn't even make sense in this problem. It's not in the domain of this problem, meaning it doesn't make sense for time to be a negative number. So we really just have two test intervals. And I'm going to use test values of 1 and 3. And when we use 1, we plug it in here, we get a -16, and then here we would get a -1, so it's a negative times another negative, so it's a positive. And when we do 3, we get a negative times a positive, which is a negative answer. We are looking for when it's greater than 0, so we'll pick the positive, so it's going to be between 0 and 2 seconds. We're not going to include the endpoints on that, so it's just going to be t has to be somewhere between 0 and 2 seconds. And in part B, it says, for what times is the height less than 640 feet? So we have to start this kind of the same way. We take the expression that represents the height, which is -16t squared plus 32t plus 1920. And we want to know when it's less than, so less than 640 feet. So we need a 0 on the right side, so we'll subtract 640 from both sides. And that comes out to be 1280. So we have negative 16t squared plus 32t plus 1280 is less than 0. Alright, now we need to factor this. Now the numbers are kind of large, but luckily we can factor out a 16 out of everything. In fact, I'm going to factor out a negative 16, which leaves us with t squared here in the first term, and then a minus 2t for the next one, and then minus 80 for the third. And that can be factored again into t minus 10 and t plus 8. So the zeros are 10 and negative 8. Notice this first factor here, negative 16, is just a constant, and that'll never be equal to 0, so that doesn't produce any zeros. So again, we'll make our number line. We have negative 8 back here, we have 10 here. Now remember, any time less than 0 doesn't make any sense. So really this negative 8 over here is not going to be meaningful in this answer. It would really start at 0 and go up. But I'll leave it there for now, and we'll see how it comes out. So to pick test values, you would use a negative 9 here, although I'm not going to bother with that for the reason I just told you. This test interval is really meaningless. Here we'll use a 0, and over here we could use something like 11. And when we plug these in, let's start with the 0. We have to remember, we have to use this whole expression here, including that negative 16. So you have negative 16, that's negative, times, and then when you plug a 0 in here, you get 0 minus 10, so that's another negative. And then when you plug 0 in here, you get 0 plus 8, so that's positive. And the final answer for that will be positive, because the two negatives will cancel each other out. Then for 11, we still have the negative 16 again, so that's negative. And then 11 minus 10, that's positive, so positive. And then 11 plus 8, which is 19, which is positive. That'll come out to be a negative answer. And we're looking for when this is less than 0. So we want the negative answer. So it's everything from 10 seconds and to the right of that. All right, it would not include 10 because there's no equality. So it would be t greater than 10 seconds.